Hello all, let's start part 3 of our lecture section. Still we are in section 1.1. In this part I will cover for you standard position of an angle or an angle in a standard position. How we should know that an angle is in a standard position, correct? There is a very easy definition how you should know that an angle is in a standard position. If the initial side of an angle lies on the positive x-axis, let me put lies also, lies on the positive x-axis, and the origin is the vertex of angle correct? We call those angles are in standard position. I'll give you here a few examples. I'll draw. First, let's draw our XY axis, correct? All of us, we are in Math 36. We know what is the coordinate system of XY, how to draw. This is your x-axis. This is your y-axis. Now, if I draw here an angle, which I'll do it with black color first, this is the origin of XY plane, correct? The black dot that I put, this is also the vertex for my angle. And from here, I'll draw the initial side on the positive side of x-axis like this. The initial side of angle is on the positive side of x-axis, and my terminal side lies on one of these quadrants, quadrant 1, quadrant 2, 3, or 4, and I'm turning counterclockwise. I call this angle in a standard position. This is your initial side. This is your vertex. You see the vertex is at the origin of XY plane, and this is your terminal side. In this case, I can say this angle is in a standard position, or maybe this one if I draw another one. First, the XY plane. This is your x-axis. This is your y-axis. Again, I'll draw an angle which the vertex is at origin, the initial side on the positive side of x-axis, like here, correct? And for example, this is my terminal side. Let's name, for example, let's say this angle is 160 degree, positive 160 degree. I call this angle in standard position. Correct? That's the meaning of that definition that I put for you. What is when an angle is in a standard position? When the vertex is at the origin of XY axis The initial side is on the positive, lies on the positive x-axis, and the terminal side lies on one of these quadrants. Correct? If you forget about quadrants, at least I'll explain something here. You can remember it again. Which one is quadrant 1, which one is quadrant 2, which one is quadrant 3. Correct? Let me draw another xy axis here for you. This is your xy plane or axis. The rectangular coordinate system, the other name that you may know. We call this quadrant or this cell quadrant 1. Here, this one, we call it quadrant 2. Here, this one, we call it quadrant 3 or cell 3, but usually we use the word quadrant. And here, we have quadrant 4. The coordinate system of xy gives you 4 quadrants. Quadrant 1, quadrant 2, 3, and 4. Now, if you have an angle that lies in quadrant 1, it means your theta is less than 90 and greater than 0, correct? Usually acute angles are lying in quadrant 1. We already know the definition. This is the quadrant 1, correct? In quadrant 2, your angle will be greater than 90 definitely, but less than what? Less than 180. In quadrant 3, your theta, you see, if this here is 90, if here is 180, what is this point? This point is actually 270, right? Because you are adding 90, 90, 90, 90, correct? Then here theta will be greater than 190 and less than 270. And in quadrant 4, your theta is definitely greater than 270, but less than, add another 90. It means this line is also 0, but at the same time, if you do a full round, it gives you 360 degree, right? In quadrant 4, theta is always greater than 270 and less than what? 360. Correct? Now, there is another topic, interesting topic about angles that you should know. We call it quadrantal angles. Quadrantal angles. Which kind of angles? We call them quadrantal angles. Angles in a standard position, whose terminal side lies on the x-axis, lies on the x-axis or y-axis, we call it quadrantal angles. The good example is 90 degree. It's a quadrantal angle. 180 degree. We call it quadrantal angle. 270. It's a quadrantal angle. Because the initial side of 90 degree, for example, you see the initial side of 90 degree lies on the x-axis and the terminal side lies on the y-axis, right? This is your 90. That's why we call it quadrantal. Or if you look to 180, right? You see, this is the x, y plane. Again, the initial side lies on the x-axis. The terminal side also lies on the x-axis. This one gives you 180 degree. Correct? And you see your angle is still in a standard position because the vertex lies on the, or the vertex is the origin of the coordinate system. Correct? Next thing that we want to discuss, I know 1.1 is a lot of definitions. It's really a long lecture. That's why I divided to 3-4 videos. But believe me, after we get out of chapter 1 and slowly start with chapter 2, you will see it's getting interesting and interesting. Even in maybe 1.3, 1.4, we slowly start with the actual trigonometric functions, but here we talk a lot about geometry also, correct? Anyway, the next topic is coterminal angles, correct? Coterminal angles. If this is your xy plane again, correct? This is your x-axis. This is your y-axis, correct? If I draw here an angle in a standard position, for example, this is my initial side, correct? And let's say, let's draw, for example, 60 degree. This is my terminal side and this angle is 60, correct? Because like this. What will be the coterminal for angle 60 degree? Coterminal. If you see, if you do couple rounds, if I start again, if I have another angle that the initial side, I'll use blue, the initial side lies on the x-axis again, and I do a full round like this, and my terminal side also should lie on the terminal side of the given angle like this. Hopefully you can see it in colors. The initial side lies on the initial side. The terminal side should lie on the terminal side. If I count this angle, that will be the coterminal of the 60 degree. Let's count. From here to here, you did a full round, which gives you 360. And you did 60 more. 360 plus 60 gives you 420 degree. Now, you can say the 60 degree and 420 degrees, they are coterminal angles. Correct? Hopefully, you will learn slowly the definition. If the initial side of an angle lies on the initial side of another angle, and the coterminal side, if I give you a better kind of definition, is the multiple of the 360, a number times 360, we call those angles coterminal angles. Another example. Let's draw this. This is the x-axis again. This is the y-axis, correct? I'll draw 110, correct? An angle 110. This is my initial side on the x-axis. 110. 110, you do it up to here 90. An angle something like this will be 110, right? Greater than 90, less than 180. This angle is 110 degree. They are asking me to find a quadrantal angle to 110. Correct? Again, I'll use blue. I start again. This is my initial side, lies on the initial side of the given angle. If I do a full round of 360, correct, and go back another 90, correct, even I do 2 rounds, I'll do another 360, go back up and come here to the initial side. Now I will count how much I have. You see, 1 round is 360, 2 round is another 360. It means 2 times 360, which gives me 720. And I did another 110 plus 110. It gives me 830. Correct? Then I can say 110 degree and 830 degrees, they are coterminal angles. Correct? This is how you know about the coterminal angles. Now, there is an example in your book. I will do it here for you. You may learn more about coterminal angles. Example number 1, find the angle of least positive measure that's coterminal with each angle, with each given angle or with each angle. Correct? Part A, they give you an angle here. The angle is 908 degree. We want to find what is the coterminal, the least positive coterminal to 908. Correct? What you do actually here, you want to use your 908 degree angle and subtract from this, because they are asking you least positive, the multiples of 360 as much as you can. You see, if I subtract from this 2 times 360, which gives me 720, it will give me the least positive coterminal for 908. Why not 3 times 60? Because 3 times 60 will be greater than 908. That's why twice, right? It means here I will get 908 degree minus 720 degree, which will give me how much? 188, right? 188 degree. Then you see 188, which is a positive angle, correct? It's a positive angle. It's coterminal with 908. If you say no, let me show you in the picture. Let's first draw 908. Positive side on the positive side of x-axis. How I can get 908? Almost 1 round, 2 round. If I do 1 round, it gives me 360. If I do another round, it gives me 720. And if I do half a round, 720 plus 180 gives me 900, right? And because it's 908, a little bit more than that, like up to here. This angle is actually 908. Now, 188 is also coterminal. Why? Because you see, the positive side lies on the positive side. You start around, come up to here, and you stop. Because it's at least, right? Up to here, 188 more, 188. The blue one is 188. And you see, the terminal side of 188 lies on the terminal side of 908. That's why we call them coterminal. Correct? In part B, they give you another angle. In part B, they give you negative 75 degree. They are asking you to find at least positive coterminal angle to 75. Negative 75. Let's draw this first. Let's see it. Where is negative 75? This is X. This is Y. Your initial side is on the X-axis. Correct? But negative 75, if you draw negative 75, actually negative 75 is here, right? Because you are going clockwise this time, this way. That will be your 75, negative 75, because you are going clockwise. Correct? Now you have to find at least or least positive angle, which is coterminal to negative 75. Draw your initial side, which is this. Go counterclockwise. Come back to terminal side of this angle. Wherever the terminal side is, stop there and count. How much is that? Draw your terminal side. 90 plus 90 plus 90 gives you 270. And how much is this side? If that is 75, this one is 15. 270 plus 15 gives you 285. 280 actually, not 85. Am I right? 285. Correct? Then this blue angle is 285. How to calculate? You have negative 75 without drawing. You have negative 75. You see, if I add 360 to my negative 75, it gives me 285, which is a positive angle, and it's the least positive angle, which is coterminal to negative 75. Correct? I'll give you a kind of table here for some famous angles and their quadrantal angles. I'll try to draw a table. It's also in your book. You can see it in your book, those of you that you already have your book. If not, until you receive your book, I can show it here for you, and also it's in my presentations. Correct? Let's name here this one. Remove this line. I don't need this line. Let's write here quadrantal angle theta. Quadrantal angle, let's say theta. Let's find the coterminal with theta. Coterminal with theta. Okay, first I have to choose my quadrantal angles. The first quadrantal angle is what? 0 degree, right? Because the x-axis, y-axis, 0 degree is also quadrantal. The terminal side and the initial side is on the top of each other. That's 0 degree, correct? What is the quadrantal angle for 0? You see, if you do a full round, then 360 can be a coterminal to quadrantal angle 0. If you go positive, if you go negative, negative 360 also be a coterminal angle with what? With 0. What is next quadrantal angle? Next quadrantal angle is 90, right? What is coterminal to the 90 degree? Negative 630 can be quadrantal. Negative 270 can be quadrantal, correct? And also 450 can be quadrantal to 90 degree. Coterminal to 90 degree, correct? Not quadrantal, coterminal. What is the next quadrantal angle theta? 90, the next one is what? 180. What are the coterminals for 180? Negative 180 can be a coterminal because you see, if this is, let me draw with red, if this is positive 180, correct, this way. If I go negative way, draw an angle like this, then negative 180 is coterminal to 180, correct? What else can be? 540, positive 540 can be. 900 will be another one, correct? Just add 360 on the top of 180, or you go negative way, correct? Some of them, there are multiple, a lot of coterminals for 180. We just name few of them, correct, as an example. What is the next quadrantal angle? The next quadrantal angle is 270, right? Then what can be the coterminal for 270? Negative 450. If you say no, let's draw this one and see that I'm right, or your book is right. First, let's draw 270. You know where is 270, right? This is your initial side. You come here. This is 270, right? This is your 270. I told you negative 450 is also quadrantal. Let's find 450. Initial side, but go negative. One round, full 360. 360 plus another 90 gives you 450. You see, negative 450 is actually coterminal to 270. Correct? What are the other quadrantals? There is a lot. For example, negative 90, the other easy one. Negative 90 is also quadrantal to 270. 630 positive, it's also coterminal to the 270, correct? These are some examples of the angles that they are coterminal to your quadrantal angles. Quadrantal angles, how many of them we have? 0, 90, 180, and 270. We call them what? Quadrantal angles, correct? I will stop the lecture here. This much is good enough for section 1.1. See you all in section 1.2.